Dear world, welcome back to the trees data structure. So in today's video, we'll be observing the entire tree structure. We'll observe the concept, the main terminologies, and the next videos onwards, we will mainly focus on the coding section because this is the video of coding and DSL lead code section. So our main focus will be only on the codes. We'll transform the diagram, the theories to the coding section. So let's start this introduction of DSM. So first in today we'll be observing the tree's basic concept, then the basic terminologies, then we'll be observing the types of trees, then tree representation and all the operations. There are lots of operations, we'll be observing all the operations one by one. So this is the introductory video where we'll be having an introduction with tree. So let's understand why do you require a tree. Let's talk about the data structures. So primarily we have data structures. In our computer science we have data structures, and the data structures are of two types. First one, linear data structure, and second one, non-linear data structure. Linear data structure, that is linear, and these are non-linear. So the linear data structures, you might be knowing that the linear data structures are first linked list. First, that is linked list, who comes on the first one, linked list. Second, we get that is stack. What we study after linked list, that is stack. Third, that we study in linear data structure section, that is queuing. So these are linear data structure. If we talk about linked list, so the architecture of linked list is like this. This is what sometimes we get linked list like this one. So this is linked list. This is linear in structure. If we talk about stack, so stack have a structure like this. This is stack, and we keep inserting elements from the ground this position. So this is stack. This is linked list, and the queue have a general structure like this, and we can insert the queue from that side, and it will execute from this side. So these are the structure. Okay, you can see the QE. So this is the QE structure. So all the structure that you can see, these are linear in fashion. Now we will be observing the nonlinear data structures. So we are keeping here. Okay. So in the nonlinear data structure that we observe, so that comes tree. Under nonlinear data structures, we get tree. Tree is a nonlinear data structure. Just look the hierarchy of the tree. It's from this side, from this side. So it grows like this. It has no linear data structure like this. And graph. Graph is also a tree, but graph is a connected tree. So these are nonlinear data structure. So there are multiple representation where we need to store the memory in more efficient way, more efficient for more optimization of memory, better usage, ascending and descending orders, we utilize the tree. So that is why we require tree, because linear data structure cannot implement all things. Only nonlinear data structures like trees perform this. So we utilize tree. So okay, we'll be observing the tree right now. So okay, now we will be understanding this nonlinear data structure, the trees. So first we need to understand, we got that this is a nonlinear data structure, as it can grow like this 1 2 3 4. It can again grow like this 5 6 7 8. So this is not following the linear structure, so that is nonlinear data structure. So we'll be understanding the important terminologies of this nonlinear data structure trees. First we'll be understanding nodes. Look, you can observe those all nodes, all those points, these things, these all those numbers, these are called nodes in trees data structure. We call them nodes. These are the things that we call them nodes. Though the first one that we can observe here, which has no anything, that means which is a starting point, this one, we call this starting point as the root. This is called the root node. That node is called as the root node. And the lines that you can see here, the lines, these lines are called edges. Those lines are called edges. So we got that these are nodes, these are edges, and this is the root. So all the nodes, now all the nodes which have the children, all the nodes that have the children. As you can see, this one is having the children of 2 and 3. So parent, so we call this that one is parent of 2. Let's understand parent. Parent is not a particular term of anyone. It is not a particular term. It is a respective term. Parent, this is a respective term. So if something is having children, if something is having children, having children, having children, then we call that it is the parent of this. That means if we can see from here, from this position, that one is having the children 2 and 3, because one is connected with 2 and 3 directly, direct connection, so we call it the children. So one is the parent, one is the parent of 2 and 3, of 2 and 3. So similarly we can see that 2 is directly connected with 4 and 5, so we call it that 2 is the parent of 4 and 5. 2 is the parent of 4 and 5. So this is what is called parent. That is what is called parent. And those nodes which are belonging, which are connected from a parent node, these are called the child nodes. So these are the child nodes. These nodes are called the child nodes. These are called the child nodes. Now we'll be moving towards more subtree. If you now you can observe these sections. If you just observe this tree, if we just notice this tree section here in another way, 2 4 5, so this is also a tree, and with respect to this tree is called the root. So this tree is now a part of this main tree. This tree is now a part of this main tree, so this is called, that's why this we can call this tree, we can call this tree as a subtree, we can call this as a subtree. We can also call this 3 as the subtree. We can also call this 3 as the subtree. It might have a one node, but that is also a subtree. We can call that as a subtree. So you understood that this is a subtree because that is the main part. So after the subtree term, we will be observing the depth of a node. We need to, there are more times like depth of a node, height of a node. So let's first understand what is this. Let's understand the tree again in architecture way. That is 1. 1 is having two children, 2 and 3, and this 2 is having additional two children, 4 and 5. These are the children of 4 and 5. Now if you observe the first one, so if we observe from here, it is the starting point. This root is the starting point, this root is the starting point, and as that is the starting point, that means the depth is at the beginning, at the zeroth level, so we call it the depth 0. This is called depth 0, and from here the depth is counted. Now as we move downward, the depth keeps increasing by what value? By 1 value. Now if we come here, it increased by 1 edge, the number of edges increased by 1, so the depth become 1. Depth is 1. If you come this level, we get the depth to be increased by 2, because there is edges 1 edges and 1 edges, so the depth is 2 at that level. So that is called depth. Now understanding the level term, depth and level, those two terms are similar. If depth is also 0, we call it level. Sometimes we call this also level, so we call this level 0. So this is level 0, this is level 1, and that is level 2. Level 2. So we can understand that in trees terminology, the term depth and level have similar impact, same impact. Level, that is equals to depth. So we understood the depth and level. Now we'll be understanding the height of the tree. We also get one more important term in trees, that is height of the tree. So we are now coming here and we need to draw the tree. So the tree is 1, 1. It has two children, 2, 3. And the 2 is also having two children, 4 and 5. The 2 is having two children, 4 and 5. 4 and 5. So now we'll be understanding the height of the tree. Now observe, this is the ground level. That is, we can also understand that this is the ground level. So the term height, ground level, that term height, we always measure it from in terms of ground level. We always measure this term height in terms of ground level like this. The more we move upward, the more the height increases. So if you observe at the ground level, we observe that this is zeroth level, this is zeroth level. So we call this that at zeroth level the height is 0. because we always measure the height in terms of ground level. So at that level, when it is ground level, we count from 0. So at ground level, we call the height to be 0. At that level, the height is called 0. Height is 0. Now look, this is the level mark, 1 inch. When it increased by 1 inch, the height is enhanced by 1. So if you observe in that level from the ground, so we call here the height is here 1. Again, if we move more upward, if we move just more upward like this, if we move up to that level, so we can observe here that now we again got one more child. So this is the one child. So total this height is 2. The height becomes here 2. So this is called the height. In tree terminology, we call this height 2. So this is height 2. That when we are at the ground level, that is leaf nodes. Leaf nodes have always a height of 0. Leaf nodes always are having the height of 0 because the leaf nodes are those nodes which are having no any children. So 4 and 5, that is leaf node. So this is the leaf node, I mean at the least level. So these are have the height of 0. But if you observe in that level, this 3 is not the most least. We have to count out the most least. That means this is the most least. Okay, now we also again get one more terminology, that is called the height of the tree. What is the height of the tree? Height of the tree. Height of the tree. We got height of individual nodes. So what is the height of the tree? Look, height of the tree is same as the height of the root node. That means whatever will be the height of a root, this is the root node. So whatever will be the height of a root that is encountered as the height of the tree. So if the height is 2 of 1, so the height of the tree will be 1. So the height of tree is the same as a root node. Same as root node. So that is the height of the tree. So now let's understand the terminology is node. So I already make you understand what is node. I've already make you understand about node, that this all those leaves that actually present, that is what we call the nodes. Now root, I make you understand the top node of a tree. This top node is called the root. I make you understand root. Edge, those all connections, these are the paths. These paths are called the edges. These paths are called the edges. Now parent. Parent, a node that has one or more children. If something is having children, that is called parent. So one is the parent. This is the parent. One is the parent of 2 and 3. One is the parent of 2 and 3. If you observe from 3, 3 is not the parent because it has no child. But if you observe from 2, 2 is also having children 4 and 5. So 2 is parent of parent of 4 5, parent of 4 5. So we can call this 2 is parent of 4 5. Now now we'll be moving towards the next. Okay, the tree structure was 1 2 3 4 5, 2 3 4 5. So that was our tree. Now child, a node that descends from the another node. Look, there is one more term in trees terminology. This is called descendants. So if we go towards this downside, so we call the node the descendants. The 2 is the descendant of 1. This 3 is the descendant of 1. Why? Because it is towards the downside. This is towards the downside. So these are called descendants. 2 and 3 are called descendants. Descendants. These are called descendants. So child, a node that descends from another node, that 2 and 3 is descending from 1 and 3. So these are called the child node. So 2 and 3. 2 and 3 is the child node of 1. Child node of 1. Child node of 1. Now subtree. Subtree, that I made you understand, that a tree found by a node. If we just observe from this particular position, so we call this is subtree. That is called subtree. Okay. Depth of a node. I've already make you understand that depth and level are same things, and that is measured from the beginning. Depth is measured from the starting point. So if you measure from here, the depth, this is the level, and the depth and level is same. 0th depth and level. depth is also 0, level is also 0. If you come to that level, so this becomes 1. The depth and level both are 1. If you come to that level, the depth and level both becomes 2. And how do we measure? We measure from number of edges. Number of edges. The edges is 1, so depth and that is 1. Height of a node. I've already made you understand that we measure the height from the ground. So if you see in terms of height, the 4 and 5 have the height 0. Height 4 and 5 is having 0. Now if you come here, the height becomes 1. If the height becomes 1. If you move here, the height becomes 2. So that is height. Now degree of a node. Look, the degree of a node is one more important term and tree. One more important term, the degree of a node. So the number of children of a node. I mean, degree is nothing but in another terminology, the number of children. If you call the degree of one, degree of this one root node, degree of one. So degree of one that is equals to number of children of one, that is number of children. So how many number of children? One children, two children. So the degree will be 2. If you measure of degree of 3, degree of 3 that is equals to degree of 3 that is will be equals to number of children of 3. And how many children this 3 is having? Look, this 3 is not having any children. This 3 is totally not having any children. So the degree will be 3. That means the degree is nothing but the number of children. So we got to understand degree and height of the tree. I made you understand. So we are finishing this session with the introductory lesson. In next lesson, we'll be moving towards the most important concept. We'll be understanding the types of trees. This is just the introductory video. We understood about the tree. In next video, we will be understanding about the tree, complete binary tree, strict binary tree, all those trees. So, okay, meeting on the next video.